Algebra 3, Chapter 7, Section 1, Using Fundamental Identities. So far we've gone over the basic definitions, the properties, the graphs, the applications of trig functions. Now we're going to learn how to use their identities to evaluate trig functions, to simplify trig expressions, to develop more identities, and to solve equations. So first of all, these are the ones we've already talked about. These are the ones that I told you really need to know these. These are ones that you need to get down. These are the ones that need to be in your memory. The rest you'll have on a formula sheet. We've seen these already. The reciprocal identities just remind us that the sine and the cosecant are reciprocals, as are cosine and secant, tangent and cotangent. The quotient identities are important. We've talked about those. If you understand the unit circle, then you should understand these. The tangent is sine over cosine. It's y over x. Cotangent is the reciprocal. With the Pythagorean identities, remember I said if you know the first one, the sine squared plus cosine squared equals 1, you can derive the other two by dividing everything by sine squared. And then that gives you, if you do that, that will give you the third one, the 1 plus cotangent squared. And then you can divide everything there by cosine squared, and that'll give you the second identity. And these are the cofunction identities. Remember we said that the reason the cosine is called the cosine, the co refers to complement. The sine and cosine of complementary angles are equal to each other. The sine of 60 degrees is the same as the cosine of 30 degrees. And that's really what this identity says. This identity is saying that the complements, the two complements have the same sine and cosine. So the sine of an 80-degree angle is the same as the cosine of a 10-degree angle. And that's what all these are about. The even odd identities, just let us know, what do you do if you have a negative in front? Well, if it's a sine, then what you're going to do, or a cosecant, is you can just pull that negative out front. If it's a tangent or cotangent, same thing. But if it's cosine or secant, the cosine of the negative of the angle is the same as the cosine of the positive. So if you kind of remember that cosecant and secant, the negative in front doesn't affect it, but it does on everything else, that will help. This section is the application of these identities, and it's really handy to have them in front of you. Jot them down while you're working out the problems. So what we're going to do is we are going to find the 6 trig functions. We know that the cosine of pi over 2 minus x is 3/5, and the cosine is 4/5. Now, if you want to give this a try on your own, pause the recording and do that. If not, keep going and we will talk through it. Okay, if the cosine of pi over 2 minus x is 3/5, remember the cosine of pi over 2 minus x is the same as the sine of x. So we know that the sine is 3/5 and the cosine is 4/5. And honestly, what you can do is you can draw a triangle to do these if you want to and label it, or you can use the identities. If we know the sine, we know the cosecant because we just flip it upside down and get 5/3. If we know the cosine, we know the secant, we flip it upside down and get 5/4. The tangent is the sine over the cosine. It's 3/5 over 4/5, and that's going to give us 3/4, and then the cotangent is going to be 4/3. Now let's try this one. Again, if you want to pause the recording and give it a go, do that. If not, continue and we will talk through it. On this one, we know that the sine is -1. Now, if you think about your unit circle, well, first of all, we know that that means the cosecant is also -1. If you think about it, the only place where we have a sign that's 1 or -1 is at one of the quadrantal angles. Okay, and specifically, sine is 1 when we have pi over 2, and sine is -1 at 3 pi over 2. So the angle we're talking about is 3 pi over 2. The sine is -1, the cosine is 0. Knowing that, using your reciprocals and your quotient identities lets you come up with everything else. The secant will be undefined, and the tangent will be undefined because they would both be over 0. Now what we're going to do here is we're going to factor and then simplify. And there's more than one correct form. Now when we factor these, what you want to do is pretend like in the first one you've got secant squared of x minus 1 over secant x minus 1. Ask yourself, what would I do if it was just x squared minus 1 over x minus 1? How would I factor the top? Because that's how you're going to factor this. The same goes for the second one. If it was x cubed plus x squared plus x plus 1, how would you factor that? Pause the recording and give these a try, and then resume, and we'll talk over the answers. Okay, for the first one, it's going to factor. If it was x squared minus 1, it would be x plus 1, x minus 1. So this is going to be secant x plus 1 times secant x minus 1. Well, the secant x minus 1s will cancel and leave you with secant x plus 1. In the lower one, we're going to factor this by parts. We're going to split it in half. We're going to factor cotangent cubed of x plus cotangent squared of x. We're going to pull the cotangent squared out, as you see there. And then the cotangent x plus 1, we'll just pull a 1 out. Okay, then we'll gather together the cotangent squared of x plus 1 times cotangent x plus 1. And then we go to our identity that says cotangent squared of x plus 1 is cosecant squared. And that finishes it up. There's nothing else you can do with that. Okay, use the fundamental identities to simplify these, and again, more than one correct form. Pause the recording, look over your identities. Let me give you a hint. A lot of times it really helps for you to change everything into terms of sine and cosine. Now, not always, but a lot of times that really helps, especially on this first one, and then you might want to distribute the sign. Pause the recording, give it a try, and resume to check your answer. Okay, like I said, if you change cosecant to 1 over sine and then distribute, you have sine times 1 over sine minus sine squared. Well, sine times 1 over sine is 1, so you have 1 minus sine squared. We have an identity that says that the sine squared plus the cosine squared equals 1. If you subtract sine squared from both sides, you get that cosine squared equals 1 minus sine squared. So 1 minus sine squared equals cosine squared. You pull a similar trick with the lower one. Now that you know that 1 minus sine squared is cosine squared, that should help you with this second problem. So if you want to pause and give it another try, go ahead. And let me give you a hint. You pull a similar trick with the denominator. So we found out from the previous problem that 1 minus sine squared is cosine squared. Using one of the Pythagorean identities and solving for cotangent squared, we get that cotangent squared is cosecant squared of x minus 1. So we have cosine squared over cotangent squared. Well, cotangent is 1 over tangent, so they changed that to cosine squared times tangent squared. And tangent is sine over cosine, so tangent squared is sine squared over cosine squared. Notice that the cosine squareds will cancel, leaving us with sine squared. All right, we're going to do a similar thing here. We're going to simplify the expression. Now, again, I would suggest you change tangent into terms of sine and cosine, but doing this is going to give you a fraction. And what you're going to want to do is give both fractions, or both terms, a common denominator. With that hint, pause the recording, see if you can do it, and resume to see how you did. So as you see here, we turned tangent to sine over cosine. And then when we multiply, we have sine squared over cosine. Well, we give the second term a common denominator. That's why we have cosine squared over cosine. Then we can add them together. Sine squared plus cosine squared is 1, so we have 1 over cosine, which gives us secant of beta. Now you're going to add these two terms together. You want to give them a common denominator, and the hint I would give you is, in this case, the common denominator is going to be the two denominators multiplied together. I would not FOIL them together, I would just put them next to each other in parentheses. Pause the recording, give this a try, and resume to check your answer. And as I said, giving them the common denominator, on the left we would have 1 minus cosine x over 1 plus cosine x times 1 minus cosine x. And on the right we would have 1 plus cosine x over 1 plus cosine x times 1 minus cosine x, and that would give us the combined form you see here. The cosines would disappear. Negative cosine x plus cosine x is 0. And we would have 2, and then they went ahead and multiplied the denominator together. 1 minus cosine squared of x, which we've discovered is sine squared of x, and 2 over sine squared of x would be 2 cosecant squared of x. Now we're going to substitute and write the expression as a trig function of theta. And that 0 is less than theta is less than pi over 2 just tells us it's in the first quadrant, so we don't need to worry about any of the values being negative. What you're going to do is you're going to take the square root of 9 minus x squared and substitute 3 cosine theta for the x. Pause the recording, give it a try, and resume to check your answer. Okay, substituting, we get 9 minus the quantity 3 cosine theta squared. And squaring that, we get 9 minus 9 cosine squared theta. Factor out the 9, and you get 9 times 1 minus cosine squared theta. As we've seen before, 1 minus cosine squared is sine squared. So we have the square root of 9 sine squared theta, which is 3 sine theta. Now this looks really scary, but it's not. We're just going to use our rules of logarithms. And remember, when two logarithms with the same base are added, you can combine them using multiplication. Pause the recording, use that rule, resume the recording to check your answer. So when two things are added, two logarithms, we can combine them by multiplication. So we have the natural log of sine x times cotangent x. Well, cotangent is cosine over sine. So the sines cancel, and you're left with the natural log of the cosine of x.